This lesson is solve the inequality. Solve the inequality. Please write the date on your paper. What does solving mean? When we say that we're going to solve, solving means finding out what number the variable represents. So if we have an x in our inequality and we want to know, well, what does that x represent? Does it represent 7? Does it represent negative 12? We can actually solve an inequality to find out what that x represents. So that's what we're going to do. All right, please copy down the notes. As always, you can pause the video to catch up if you need to. This says something that we've already learned, actually, over the past several lessons. The ways to simplify two expressions. So number 1 and number 2 are things we've already studied. We've simplified that two expressions that we're comparing. We've simplified them by taking away zero pairs. That's the first thing we can do. And we've already learned that we can also take away the things that are the same or the things that are in common for both expressions. So when we have two expressions and we want to simplify them because we're comparing to see which one's greater or which one's smaller, we can do these things to simplify the expressions. There's also a third thing that we can do to simplify two expressions. So the third one, we're going to copy down. It's that we can add something to both expressions so that zero pairs can be taken. I'm going to show you exactly what I mean here in just a moment, give you an example. But we've just added another legal way of simplifying two expressions. So if we say these are legal ways of doing it, that means we're allowed to do these things. We're not breaking any rules when we do these math activities, because we can take away zero pairs from one side or the other side. We can take away the things that are the same on both sides, both expressions. And the third thing is we can add something to both expressions so that zero pairs can be taken away. So that just means if we want to add 5 to one side, we could add 5. We need to add 5 to the other side. So whatever we add for one expression, we have to add the same thing for the other expression. And we can do that to make zero pairs, which will help us to simplify. So let's look at an example. We'll call this example A. So we're going to have two expressions. The first one is x plus 2 is less than, and then the other expression is just a number, just 5. X plus 2 is less than 5. So this is like having two expressions side by side. The first expression is x plus 2, and then on the other side, the other expression is 5. In the middle, we're saying that the first one is less than. This one has to be less than 5. Okay, so what we're trying to do is we're trying to solve, and we found out earlier that solve means finding out what number the variable represents. So x is our variable here. What number is represented by x? So this is a number, but we got to figure out what number it is. All right. Well, when we look at this expression here, I don't see any zero pairs. We have some positives, positive 2, but I don't have any negatives, so I can't take away zero pairs. And there's definitely no zero pairs on the right side. we could take away something that both sides have. That's one thing we could do. We have positive 2 and here we have positive 5. But instead of looking at it that way, what I want to do is I want to show how we can use number 3 to simplify. So number 3 says add something to both expressions so that 0 pairs can be taken away. All right, so this is what we want to do. Since we want to know what x is, we're going to try to get the x all by itself on this side. We want it to be all alone. What can we add so that the plus 2 will go away? We need to add something so that the plus 2 will go away. Well, we could make 0 pairs if we add 2 negatives. So for the expression on the left-hand side, we have an x, which we don't know what that, and we don't know what that is, but the plus 2 will go away if we add a negative 2, because now we can make positive 2 and negative 2 end up being 0 pairs. But it's really important, add something to both expressions. That's what it says. So we've added negative 2 here, added 2 negatives. We have to add negative 2 on this side also. So we're going to add a negative 2 on this side. The reason we chose to add negative 2 is because we're trying to get the x to be all alone. And that helps us because plus 2 and negative 2 added together makes 0. That's gone on this side. Over on this side, 5 plus negative 2 is 3. So we're working down here. So these added together make 3. And over here, the 2's are gone, but the x has to come down here. The x is here. And we keep the less than sign in the middle. So now we end up with the expression on the left is just x. The expression on the right is 3. And this tells us x is less than 3. And we can see if that's true by kind of reasoning it out, by thinking about this. The original expression said x plus 2, and that has to be less than 5. If we put a 3 there for the x, 3 plus 2 would be equal to 5. So that's not going to help us because we don't want equal, we want less than. So 3 wouldn't work. If we put something bigger than 3, like 4, then it would be 4 plus 2 is 6. But 6 is not less than 5, so we need something here for x that's less than 3. Like, for example, if I pick 2 and put a 2 there. If I put 2 in for x, it would be 2 plus 2 is 4, and that's less than 5, so that works. So by solving the equation, solving the inequality, this is called an inequality, because they're not equal to each other, these two expressions, we found out that x has to be something less than 3. Less than 3. And that's our answer. So we could put a box around that. X has to be less than 3. Example B. Let's try another one. This time our expression on the left will be -1. And -1 is going to be less than or equal to x minus 7. All right, remember that we are solving inequalities, which means we're trying to solve to find out what that variable represents. Remember, the variable could be really any letter. It could be N or A or W. In this case, it's X. So let's figure out what X is. Well, we know that we're allowed to take away 0 pairs, but there are no 0 pairs on either side. We could take away the things that are the same. Here's a -1. On this side, we have -7, which is just like -7. So we could take a negative away from both sides. But let's focus on our new method for simplifying. Let's do this. Let's add something to both expressions so that 0 pairs can be taken away. So we're going to add something to both sides. what I really want is I want the x to be by itself on the right side over here. So what could I add to this side? Oh, maybe first we got to clarify this. This says minus 7, but we've learned that when we're when we are subtracting integers, that it's good to change the subtraction to addition. So let's change this to addition, and we learned that what we do is we change it to addition with one line, and then our second line changes the sign of the next number. So this positive 7 becomes a negative 7. So originally it was x minus 7, but that's the same as x plus negative 7. So now what could we add? We have a negative 7. What could we add to the negative 7 to make it go away so that x will be by itself? What could we put in there to make 0 pairs? If we have negative 7, yeah, we could add a positive 7. So I'm going to add in a positive 7 because those will become 0 pairs, which means that's 0. It's all gone. But remember I said earlier, if I add something, I've got to add it to both expressions. So I've added 7 here. I have to add 7 on this side also. Now we can see what x is going, how x is going to compare to the left side. Because over here we're just left with the x. This is gone. And then in the middle we have less than or equal. On this side, negative 1 plus 7. So negative 1 plus 7, we could do 7 minus 1 is 6. And then we could ask ourselves, are there more positives or more negatives? There's definitely more positives, so it's a positive 6. All right, so what we just found out when we solved, we simplified both sides and we solved to find that x is greater than or equal to 6. If we read it from this side, it would say 6 is less than or equal to x, but I always like to start with the variable when I read these inequalities. So let's start on this side. We'll read backwards. X is greater or equal to 6. So that means in this original inequality, we would have to have a number that's either 6 or greater here. See, if I put a 6 here, it would be 6 plus negative 7 would be negative 1, and that would be equal to negative 1. So that would work. But if I put a number greater than 6, like let's say I put 8, 8 plus negative 7 would be positive 1, and positive 1 is greater than negative 1, so that would work also. So we've figured out that x has to be anything that's greater or equal to 6. That's our answer for x. We've solved it.